It's time to set up our control parameters. So what we want to do now is to click this button right here and then click Set Control Parameters. This is going to be setting our simulation time, our time control, some global data modification controls, the processor switches. We don't have anything to turn on right now because we have to develop that data before we can turn on the switch, and then time-lapse control. So let's start with simulation time. We are running a 100-year, 6-hour event. So our project is small enough that that can drain in about 10 hours. So we can set this here to about 10 hours. Our output interval can be 0.1. That's a default, and it's a good output interval for most projects. If you have maybe tailings dam project, maybe set that like lower than 0.1. I'm going to set it to detailed graphics, but it won't actually apply it until I have added some water to the model. So it's just going to ignore it for the time being. And the update interval for the detailed graphics, meaning that you're going to be able to see it run graphically, and it's going to update at every 10th of an hour. You can see from here that our units are English. And let's see, we'll set this limiting fruit equal to 0.9. And we'll then this default for the shallow n is 0.2. Not going to explain these variables just yet. We'll take a look on where to find information about them in just a second. And then if we change to numerical stability parameters, the surface detention can be set to 0.0042, and the courant for the floodplain will be using the default courant variable. So these are going to keep your model stable and control your time step so that your model is going to use a time step that matches the grid size and the configuration of your project. And I'm going to click Save, and I want to export that data really quickly. I'm not ready to export my project yet, but I'm going to export that data really quickly into a project let's just do this. We'll do export, and let's make this, and that looks good. We'll select that, but we don't want everything. Let's just uncheck everything and click OK, and we've just exported these two projects. Okay, I'm going to turn that off. I'm about tired of hearing that beeping in my ear. Okay, now we just exported that data right here, and we have these two ASCII data files. I'm going to open these in Notepad. So cont.dat on the top and toler.dat on the bottom. Let's just make that smaller. And you have a bunch of files here that don't mean anything to you. That's perfectly okay. We have data input manual for that. So if you go back to your self-help project and you go back 2 levels into your documentation for Flow2D, and you open up your manual or flow_help manuals, you can open the data input manual and the Flow2D reference manual. Those, if you open the data input manual, we're going to go to chapter 4, where we have a file description of every ASCII data file that we have that we export with the software. So go to cont.dat, and let me get off there, and you see that that should pretty closely match what we have right here, except this one has some processor switches turned on. Now this file, let me make that a bit smaller here. This file will match this position, line 1, line 2, etc. And this would be line 9. And you can see here that our simulation time, the variable is called simult, and our output interval, the variable is calledtout. And so if you come down into the variable description table, you can find simult because it's alphabetical. Oops, that's supposed to have a T right there. And it says simulation time in hours.tout says that it is the output interval in hours that the hydraulic data is reported to the various output files, and the various output files have an extension of star.out. It is a real number, and its range is 0.01 to 24 hours. So you can get data printed out at every 0.01 hours or every, and I think if you leave it to 0, it's going to give you, it's going to default to 0.01, or every, as high as every 24 hours. So there'll be the name of the variable, the type of variable. It could be a switch, an integer, a real number, or a character, and then a description and units would be over here. And then extra information, extra instructional comments below. And then you can see another example would be the toler.dat, and that is this guy right here. And you can see that we have the tol global, depth tol, a variable we don't use anymore, so it's going to ignore that one, and a cont number. In this case, we only have a floodplain. We don't have channels or streets, and a time accelerator number. And if you don't know what to set these to, leave them at the default. Okay. And then of course, the variables. So let's just take a look at the tol global. So 0.004 up to 0.5. Surface detention. Tol global is a minimum value that the flow depth must achieve before it starts to share with its neighboring grid elements. A typical river flood value might be 0.1 feet. A small value is used for rainfall runoff or shallow models. If you're doing something like a tailings dam, you might go up as high as 0.1 meters, because a tailings dam model has so much water that surface detention doesn't really change the floodway progression or the dispersion of that water in the downstream direction. Okay, so that's your data input manual. It also gives you a description of output files, but we'll check that out later. FlowDD Pro Reference Manual has instructions on the governing equations, the solution algorithms, volume conservation, and stability information in Chapter 2. Chapter 3 is the modeling system. You can also get somewhere in here the units. And Chapter 4 is modeling specific features, the specific components.